Okay, so today we are going to talk about sum of cubes. So before we do that, let's walk through our factor map one more time and make sure we remember. So we have a polynomial, and we check to see if it needs to be simplified or combined like terms, rearranged, put it in standard form, or remove that greatest common factor. All right. Now, if any of this needs to be done, take care of it first, and then what you're left with, you're going to check on to see if it falls under any of the categories below. Now, if it's already been done and you're good to go, then we go ahead and move down to these categories. So now you're either going to have a binomial, a trinomial, or a four-term polynomial. Now, we've already been talking about binomials. We've talked about difference of squares, what to do if we come across one of those special cases. We've talked about difference of cubes, and today we're going to finish up binomials with a sum of cubes, okay? Don't forget, once you've done that, repeat your processes as needed and always, 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 always prove your answer, okay? So keep that in mind. All right, so let's start our notes for today. So first off, we are doing sum of cubes today. So we always start with 3 steps. We always simplify, we always rearrange, and we always remove a greatest common factor, okay? This is what we do every time, all right? Now, again, remember that you have to know how to find whether something is a sum of cubes or not. So first off, we know that it's a binomial because it's in that category on our map. So we know that it's a binomial. All right. Second thing is that it's going to be a sum this time, and sum means addition. All right. So we're dealing with addition this time. The powers, it's a cube, are going to be divisible by 3. And we're going to be dealing with numeric cubes. It's going to be very similar to a difference of cubes. The only difference is the sign. It's going to be a sum rather than a difference. So the numeric cubes here, again, 1, 8, 27, 64, 125, and so on, okay? Now, once you've found that something is a sum of cubes, and we know that it is, we're going to go ahead and factor it the same as before into one binomial and one trinomial. Okay? All right. And the pattern here for this one is going to look very similar to the pattern for difference of cubes with just a couple of small differences, okay? And so this is going to be really great practice for what we were already doing, but also hopefully will help build your confidence on this as well because it's going to be very, very similar to the last one with only one small change, okay? So first off we need to do is check for simplify, and it has already been combined. Rearrange, it is in standard form, and remove a greatest common factor. There is no greatest common factor here. So we can go ahead and get started. All right. Now, we do need to check to see if this is a sum of cubes. So sum means addition. We got that. It is a binomial. We know that. The powers are divisible by 3. Okay, well, 3 is divisible by 3, so that's good. And then numeric cubes. We have a 27 and an 8. So 27 and 8 are both numeric cubes. So we know that this is a sum of cubes. So now we're going to split this into one binomial and one trinomial. So I'm going to go ahead and put my spots in. Okay? All right, so now, just like difference of cubes, all right, we start with a cube root. All right, so we're going to take the cube root of this right here. So first off, we have to take the cube root of 27. Now remember, you can do that in your calculator. So I'll show you one more time how to do that. All right, we turn our calculators on. We hit the math button, which is this button right here below the green one. And we go down to the fourth one right there, which has a little 3 and then the square root symbol. So that's cube root. And we put in 27 and we find out that the cube root is 3. Okay, so we found that. So let's see. We're doing cube root of 27b cubed. So that's going to be 3. But then we also have to take the cube root of this b cubed. And remember what I told you last time. To find the cube root of an exponent, we just divide the exponent by 3. So b cubed, 3 divided by 3 is just 1. So that's going to leave us with just the b to the first power. So 3b is what's going to be our cube root here. Okay? Now, here is the only difference between a difference of cubes and a sum of cubes, is this sign right here. And we start with, remember SOAP, that acronym, the same sign, the opposite sign, and then go to always positive. So 3 signs, same sign, opposite sign, always positive. Now in difference of cubes, we started with difference, so subtraction. This time we're talking about addition. We're talking about a sum of cubes. So that means we're going to start with a plus sign instead of a minus sign. Okay, so we use the same sign here. We're going to use plus sign. Okay? Now, next step, same as in difference of cubes, we take the cube root of this number right here. Okay, so we're going to take the cube root of 8, and again, you can use your calculator on that. All right, you can hit the math button, sorry for the glare, go down to number 4, and then type in 8 and enter, and you get that the cube root is 2. Okay, so we can put in a 2 here. All right, now the rest of this is again the same as what we were doing before. So we have to square a, and remember a is this term right here, and if you can't remember, it's right here in this pattern. A is the first term of your factor, your first factor. So we need to take 3b and square that. Okay, so 3b times 3b, well, 3 times 3 is 9, b times b is b squared. So we end up with 9b squared. Okay, now here again is where it's different from a difference of cubes. We flip to the opposite sign this time. And opposite of addition is subtraction, so we switch to a subtraction here. Okay. All right, now our middle term, remember, is to multiply A and B. So that's these two terms right here. So we're going to be multiplying 3b times 2, which gives us 6b. So 6b goes here. And then remember, this sign is always positive, so always positive. We put in a plus sign here. And then the final step here is going to be to square that b again. So here's the 2. We're going to square it to get 4. Okay, and so 4 is what goes there. Now, here we're going to check. We're going to repeat the powers if the process, repeat the process if the powers are not 1. So here we do have powers of 1. So this is fully factored. Now over here, we would need to check it with our factor test, but we haven't learned that yet. So we're going to leave this as is, but in the future you would always check this trinomial as well to make sure that it doesn't need to be factored. Okay, so just keep that in mind. In the future we would check that, just not today because we haven't learned that yet. Okay, so we're good. We're going to call that factored, and we're going to move to prove our answer. So I'm going to choose to prove, and remember that means I take these two things and I multiply them back out. So 3b plus 2 and 9b squared minus 6b plus 4. Alright, and remember, as we're multiplying this, it's going to get maybe a little bit messy, but that's okay. Alright, we're going to take the 3b and multiply it by all 3 of these terms. Then we're going to take that 2 and multiply it by all 3 of these terms. Okay, so 3b times 9b squared is 27b cubed. 3b times negative 6b is negative 18b squared. 3b times 4 is 12b. 2 times 9b squared is positive 18b squared. 2 times negative 6b is negative 12b. And 2 times 4 is 8. Okay, and so here we start to combine our like terms. Negative 18b squared and positive 18b squared is 0. 12b and negative 12b is 0. And so what we're left with is 27b cubed plus 8. And we look here, that is what I started with, that is what I wanted. Okay, so I've proved that these two things are factors. And so our final answer are the two factors that we were looking for. Okay, and so that's the process. It's going to be, again, the same process as difference of cubes. The only difference are our signs. Okay, just make sure that you keep same sign, opposite sign, always positive. Okay, everything else is going to be the same. Now, you do have 4 practice problems down at the bottom that I want you to complete, so here they are. I want you to do a to the 9th plus 125. I want you to do d to the 9th plus 216. I want you to do y to the 27th plus 216. And I want you to do 8y cubed plus 64. okay? Now, on this one, number 4, you are going to have to remove a GCF first, okay? So don't forget about that. Now, once you've checked these with me, I'll give you the go-ahead, and you can start on the next 5 practice problems. So those are going to look like these. Remember, on number 1, you're going to have to rearrange. That is not in standard form, okay? Number 2, take out your greatest common factor. Number 3, you do need to rearrange, and you do have a greatest common factor that needs to come out as well, okay? Number 4 looks good. You should be able to do that one pretty easily. And number 5 needs to, looks like we just need to pull out a greatest common factor on that one, okay? So take your time on those. Let me know if you have any questions. I'll be happy to help, and when you're finished, just send them to me and let me check them for you, okay? All right, guys, let me know if you need anything, and I'll be here to help.